Welcome to The Explainer. Today, we are going way, way back in time, 74,000 years to be exact, to look at the single biggest catastrophe our species has ever faced. We're going to explore a moment when humanity was pushed right to the edge and uncover this beautiful but terrifying scar it left, not just on our planet, but deep inside our own DNA.
All right, let's just jump right in with a really fascinating puzzle. You look around, there are 8 billion of us on this planet. All this incredible diversity in how we look, our cultures. And yet, genetically, we are more alike than a single troop of chimpanzees in one forest. I mean, how is that even possible? Well, the answer, it seems, lies in a near extinction event, a single moment in deep time that connects every single one of us here today.
So, to really get our heads around this, there's a key idea we need to talk about, a genetic bottleneck. Okay, imagine you have a bottle full of marbles, all different colors, right? Each color is a different genetic trait in a big population. Now, what happens if you tip that bottle over and only a tiny handful of those marbles fall out? That new, small group, it has way less variety than what you started with. That's exactly what a bottleneck is. It wipes out a huge part of a population, and the few who survive become the new blueprint, losing so much of that original diversity for good. And here's where it gets personal. Our own genetic code is basically screaming that this happened to our ancestors. It's like a detective story, but it's not written in stone, it's written in our genes. And it all points to this one terrifying moment in our shared past when our numbers got so small that we almost vanished from the face of the earth entirely. So, what on earth could cause a disaster on that kind of global scale? Well, let's meet the prime suspect. To do that, we have to go to the island of Sumatra in modern-day Indonesia. It's the site of a truly planet-altering eruption that would change the course of human history forever. About 74,000 years ago, something happened here that is almost beyond imagination. The Toba supervolcano just unleashed. It was an eruption so powerful, it is still the largest explosive event our planet has seen in over 2 million years. And just to be clear, this wasn't just a volcano blowing its top. This was the Earth itself unleashing a force of incredible power. Now, this is where the scale of it all really hits you. I mean, we've all heard of Krakatoa, right? The 1883 eruption that was heard thousands of miles away, or maybe Tambora in 1815, which was so huge it caused the year without a summer and led to famines in Europe. Now look at Toba. It absolutely dwarfs them. It wasn't just bigger, it's estimated to be over 100 times more powerful than even Tambora. It's a scale that is it's really hard to wrap your head around. If you want to put a number on it, Toba blasted 2,800 cubic kilometers of magma and ash into the atmosphere. Honestly, a number that big is almost meaningless by itself. It's just a colossal amount of the Earth's insides being hurled into the sky in what was probably just a matter of days or weeks. And this is how we can start to understand that number. Picture the iconic Mount Fuji in Japan. Now imagine having enough molten rock and ash from this one eruption to build not one, not two, but dozens of mountains just like it. That is the unbelievable, world-shaping power we are talking about with Toba. And all that material, it didn't just fall back down. It was shot way up into the stratosphere. And it formed this thick blanket of sulfur dioxide and ash that wrapped around the entire planet. This planetary veil, it reflected sunlight back into space. And that triggered what scientists call a volcanic winter. Global temperatures plummeted, plunging the world into a sudden artificial ice age that would last for years, maybe even a decade. Okay, so how do we even know all this? This isn't just some wild guess. It's a story that's been pieced together over decades of really careful scientific detective work, following clues from all over the globe that all point back to this one single cataclysmic event. You know, the investigation really got started in the 1970s when geologists in India kept finding these huge, mysterious layers of ash that had no local source. Then, in the 80s, they managed to date those layers to right around 74,000 years ago. At the same time, but totally separate, geneticists studying our DNA in the 90s came up with the bottleneck theory. And then, in the 2000s, everything clicked into place. Evidence from polar ice cores and climate models finally confirmed the eruption's devastating global impact, connecting all the dots. And the evidence, I mean, it's truly global. We're talking ash layers several meters thick in India, Toba ash confirmed all over Southeast Asia,
And get this, they even found it at the bottom of Lake Malawi in East Africa, thousands of kilometers away. And tiny, microscopic traces were found locked in the ancient ice of both Greenland and Antarctica. This eruption literally left its fingerprints all over the planet.
So, on one hand, we have this massive geological catastrophe, and on the other, we have this huge human genetic mystery, and they both date to the exact same time. This is where those two stories collide and form what's known as the Toba catastrophe theory, a really dramatic idea that tries to explain our own origins. To really get the full impact here, let's just paint a quick picture of the world at that time. Our ancestors, Homo sapiens, we were a pretty young species, mostly living in Africa and just starting to make our way across the globe. But, and this is important, we were not alone. You had Neanderthals thriving in Europe, the Denisovans in Asia, and other human-like species scattered around. It was a world with many different kinds of humans, not just us. And that brings us to anthropologist Dr. Stanley Ambrose. Back in 1998, he was the one who put all these pieces together in a bold new way. He proposed that the Toba eruption wasn't just some big geological event. He said it was the direct cause of that genetic bottleneck. It was the catastrophic filter that pushed not just our species, but maybe all human species right to the very brink of survival. So the chain of events was just brutal and terrifyingly quick. The eruption blocks the sun. The world gets cold fast. The plants start to wither in the darkness and the cold. The animals that eat the plants begin to starve, and the ecosystems that our hunter-gatherer ancestors depended on for absolutely everything, they just completely collapsed. For those small, scattered bands of early humans, this was a true apocalypse. So here it is, the really shocking part. How small did our population actually get? Now, there's definitely some scientific debate about the exact numbers, but some estimates suggest that the total number of surviving human individuals, or at least breeding pairs, may have dropped to as low as 1,000. Just think about that for a second. The ancestors of all 8 billion of us alive today could have been a group small enough to fit inside a single movie theater. And that brings us right back to where we started. That catastrophic population crash is the leading scientific explanation for the mystery we kicked off with. It's the reason why all humans, despite all our wonderful differences on the surface, share such a recent common ancestry and have such low genetic diversity. We are all descendants of the tough, incredibly resilient few who made it through. But you know, the story of Toba isn't just some fascinating piece of ancient history. It's a really profound lesson about how fragile our planet is, about human resilience, and it's also a chilling warning that echoes from our deep past right into our world today. And what happened to the site of this gigantic eruption? Well, today, it's Lake Toba. It's a stunningly beautiful 100-kilometer-long lake that peacefully fills the collapsed crater, the caldera of the supervolcano. It's this serene, idyllic landscape, a truly beautiful scar left behind by one of the most violent events in our planet's recent history. And that really leaves us with a pretty sobering thought, doesn't it? Our ancestors, with little more than stone tools and fire, somehow found a way to survive. They endured. But could our complex, interconnected global civilization, so dependent on technology, a stable climate, and global supply chains, could we survive a similar event today? That's a question that is absolutely worth pondering. What we've gone over today is really just the tip of the ash cloud. The full story of Toba is packed with incredible scientific debate, new discoveries happening all the time, and just fascinating details about the ultimate survival story, our own. If you want to go deeper, our complete guide explores the full climate impact of that volcanic winter. We take a deep dive into the specific genetic evidence, and we also look at the scientific controversies and the really compelling arguments against the catastrophe theory. Plus, we take a look at Lake Toba today, this vibrant center of unique culture and tourism. Thanks so much for joining us for this explainer. The story of Toba is, in a very real sense, the story of every single one of us. It's a powerful reminder that we are all the children of survivors. We'll see you next time.
Let's talk about a moment deep in our past, a moment that almost became our very last. We're going to explore a single, terrifying event that pushed our ancestors to the absolute ragged edge of extinction.
Yeah, you heard that right. 74,000 years ago. Imagine, our entire species, all of humanity, suddenly shrunk down to a population the size of a tiny village. This was the terrifying reality of the Toba event, a supervolcanic eruption that came incredibly close to erasing us from history altogether.
So just how well do you know the catastrophe that literally shaped who we are today? Well, let's find out. Welcome to the Toba Survival Challenge. I've got 10 questions for you. Your mission, should you choose to accept it, is to see if you can nail every single one. You ready? Let's do this. All right, question 1. Let's start with the basics. The epicenter. Where on Earth did the ground literally rip itself apart and change the world forever? Any ideas?
And the answer is Sumatra, Indonesia. The site today is known as Lake Toba. But don't let the word lake fool you. This isn't just some picturesque body of water. It's a 100-kilometer-long collapsed magma chamber, a massive permanent scar on the face of our planet that's so huge you can see it from space. It's a constant reminder of the incredible power simmering just beneath our feet.
Okay, so you've nailed down the where. Now let's talk scale, because this is where things get, well, honestly, a little insane. So for question 2, how long ago did this happen? And just how big was it on the official scale?
The answer? It all went down about 74,000 years ago, and it clocked in at a VEI of 8. Now, what does that mean? It means it's the highest possible rating, the absolute top of the chart. There is no 9. To put that into perspective, this monster spewed out enough rock and ash to build dozens of mountains the size of Mount Fuji. This wasn't just a big eruption, it was a planet-altering cataclysm.
You know, the initial blast was devastating, for sure. But that was just the opening act. The real, silent killer was the dramatic climate change that swept across the globe afterward. So, what specific chemical did Toba pump into the atmosphere that kicked off this global winter?
The villain in our story is sulfur dioxide. Massive amounts of it shot straight up into the stratosphere. Once it was up there, it formed this planet-wide shield of tiny particles that literally blocked the sun. Imagine a veil being drawn over the entire world. This triggered a sudden, terrifying drop in global temperatures, plunging the planet into a deep freeze that starved everything, including our ancestors.
So we've got a planetary deep freeze, a dying world. It's pretty clear this event didn't just change the weather, it fundamentally changed us. This brings us to question 4. We know the eruption happened, but what's the name of the famous scientific theory that connects that eruption to our own evolution? It's called the Toba catastrophe hypothesis, or sometimes the genetic bottleneck theory. And here's the so what. This theory explains a really weird fact about humans. We have shockingly low genetic diversity. In fact, any 2 humans are more genetically alike than 2 chimps from neighboring groups. Why? Because our ancestors were squeezed through this tiny evolutionary bottleneck. We are all descendants of the incredibly small and incredibly lucky group that somehow made it through.
And that brings us to a number that really hammers home just how tight that bottleneck was. How small did our population get? What was the absolute lowest, most chilling estimate of how many of us were left?
1,000. Just let that sink in for a second. 1,000 people. Now, broader estimates range up to maybe 10,000, but some credible models suggest it could have been as low as 1,000 breeding individuals. Our entire species, which is now over 8 billion strong, was once reduced to a group that could barely fill a small concert hall. The sheer luck involved in our survival is just staggering.
Okay, so you might be thinking, how on earth do scientists know all this with such confidence? It sounds like science fiction. Well, it comes down to some brilliant geological detective work. They found a specific piece of evidence, a sort of geological fingerprint that the eruption left all over the world. What is that layer called?
It's called the Younger Toba Tuff, or YTT for short. The best way to think about it is like a single layer of dust that settled over the entire planet at the exact same moment. So when scientists find that specific ash layer in an ice core from Greenland, and then they find the exact same layer in an archaeological dig in India, they know those 2 locations were experiencing the same global event at precisely the same time. It's the ultimate geological clock.
And this geological clock, this Younger Toba Tuff, it has shown up in some truly jaw-dropping places. Which brings us to question 7. What was one of the most surprising and important places this ash was discovered, proving just how far that cloud really traveled? Lake Malawi, in East Africa, thousands and thousands of kilometers away from the eruption. And why is that such a bombshell discovery? Because that's the cradle of human evolution. Finding Toba's ash right there is the ultimate proof that this catastrophe was inescapable. It means there was nowhere to run, nowhere to hide. Even our ancestors half a world away felt the direct impact.
You know, we keep using this phrase super eruption, but the words can lose their meaning without some context. So let's do a little comparison. How does Toba stack up against the biggest eruption in recorded human history, Mount Tambora, the one that gave us the infamous year without a summer?
Yeah, it's not even a fair fight. It's like comparing a firecracker to a tactical nuke. Toba was about 40 times bigger than Tambora. It was over 100 times bigger than the famous Krakatoa eruption. This really shows you the difference between a historical disaster and a true planetary supereruption with the power to alter the course of life itself.
So we've got all these puzzle pieces, right? The geology, the climate records, the weird genetics, but it took one brilliant person to put them all together and see the terrifying big picture. For question 9, who is the researcher who first proposed this whole groundbreaking idea?
That credit goes to Dr. Stanley Ambrose. His work back in 1998 was a total game changer. He was the one who connected the dots, bridging all these different scientific fields, genetics, geology, climate science, to tell one single powerful story. He basically forced us to see our own evolution not as some slow, steady march forward, but as a brutal story of survival, shaped by violent, sudden disasters.
Okay, final question, and this one really widens the lens. It's easy to forget that 74,000 years ago, we, Homo sapiens, were not alone on this planet. Who else was out there? What other kinds of humans were struggling to survive when the sky went dark? We shared the world with Neanderthals in Europe, the mysterious Denisovans in Asia, and even other groups like the so-called hobbits of Flores, Homo floresiensis. The world was a busy place for the human genus. And the Toba event? Well, it acted like a giant reset button for the entire human family. It completely changed the rules of the game, and it may very well be one of the key reasons why, today, we're the only ones left standing.
And that is the end of our challenge. So, how did you do? Did you get a perfect score? You know, whether you got 10 out of 10 or 0 out of 10, the big takeaway is the same. The Toba event wasn't just some ancient disaster. It was the crucible that forged modern humanity. Our very existence is a testament to the resilience of those few who endured.
Now, obviously, this has just been a snapshot. The scientific debate around the Toba hypothesis is actually really fierce and fascinating. So if you want to dive deeper into the controversies, check out the raw climate data, and see what Lake Toba is like today, you have got to check out our complete guide. Thanks for taking on the Toba Survival Challenge.